1.3 Graphing Polynomial Functions Math Lab. Okay, so there's a math lab in your textbook that I want you to do. I just want to go through a couple of things with you, just some definitions to make sure you remember them from past courses. Okay, so a polynomial function is a function that contains only the operations of multiplication and addition with real number coefficients, whole number exponents, and two variables. So y and x. A degree is the highest power of x in a polynomial. It determines what shape the function makes. The leading coefficient is the term that goes with the highest degree. It affects the direction the graph opens, or the end behavior. And the constant is the fixed number at the end that does not change, and it's our y-intercept. So for this one, our degree is 4. Our degree is 4. Our leading coefficient is 2, and our constant is -1. And the shape that it makes is a quartic. That's what they're called. So we have not done quartics before. Okay, the next one, the degree is 2 because of this exponent. The leading coefficient is 2, and the constant is -1. The shape it makes is a quadratic or a parabola. I don't want to write that word. Okay, the next one, the degree is 3 because it is the highest number. The leading coefficient is -4. The constant is -3. And then the shape is quartic. Okay, next one. Even when I distribute this 0.5 and my degree is still 1. My leading coefficient is 0.5, and my constant would be -1. So 0.5 times -2. The shape is a line. It's linear. Okay, this one, the degree, we have to multiply our x's together, so the degree would be x to the power of 2. The leading coefficient, I'm going to multiply all the front things. So 2 times x would be 2. To get my constant, I'm going to multiply all the back things. Oops. So 2 times -2 times -3, which would be 12. I don't know why I changed colors. The shape is quadratic. I have more room down here. Okay, next one. My degree is, I have 1, 2, 3 x's, so 3. My leading coefficient would be 3x times x, so 3. My constant would be nothing, 0. And the reason why is because there's an x here, there's never going to be a number by itself, let alone. And the shape here is cubic. Okay, coordinate plane, talking about the quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. We use Roman numerals so that we don't confuse ourselves with numbers. Okay, so we're going to sketch the types of graph and the end behavior and the leading coefficient. So if I have a positive leading coefficient for a constant, it's going to be like this. Also, the degree of a constant is 0. If I have a leading coefficient that's negative, it would be down here. So my end behavior would be from quadrant 2 to quadrant 1. And this one, it would be from quadrant 3 to quadrant 4. Okay, line. If my leading coefficient is positive, it will go up. If my leading coefficient is negative, it will go down. Remember that the degree for a line is 1. My end behavior is quadrant 3 to quadrant 1 for positives, and quadrant 2 to quadrant 4 for negatives. And there's lots of different ways we can draw lines. I'm just drawing an example. Okay, quadratic has a degree of 2. If the leading coefficient is positive, it'll open up. If it is negative, it'll open down. The end behavior is 2 to 1 for a positive, and 3 to 4 for a negative. Okay, cubic. If it's first of all, degree is 3. If it's positive, it could look like that. If it's negative, it could look like that. My end behavior is from quadrant 3 to quadrant 1 here, and quadrant 2 to quadrant 4 here. What you should be noticing is that this is the same as this. So constants and quadratics are the same. You should also notice that linear and cubics are the same. And what they have in common is if the degree is even or odd. So a quartic, if you were to take this knowledge, is going to be the same as a quadratic. So degree is 4. Oops, I wanted to be using red. Degree is 4. It looks something like that, or something like that. So if it's positive or if it's negative, and it opens down. So our end behavior is going to be 2 to 1 and 3 to 4. Without even doing a quintic, which is to the power of 5, I can assume it's going to be the same as a cubic or as linear. So our degree is 5. So I know that a positive is going to be like this, quadrant 3 to quadrant 1, and I know a negative is going to be like this, quadrant 2 to quadrant 4. So a quintic would be like nah. Is that right? 1, 2, 3, 4, 5. Yeah. And like that. It could look like that. So, using this information, go do the math lab. Use a graphing calculator if you have one. If you don't, go on Desmos. I put a link on the website of the Google Classroom or wherever it is, or you can just Google Desmos and get a calculator, hey? Or you can do it on your phone or on a computer, whatever. And just go through the math lab, fill it all out. There's a lot of typing in to the calculator, but honestly, good skill to use. Okay, I hope you feel a little bit more comfortable with visualizing graphs by the time this is over.